Today's curiosity is lubricated by Cold Brew Coffee Stout from Little Brown Jug Brewing in Winnipeg. They suggest that it's got earthy and roasty flavors with cold brew coffee to pick you up in your afternoon. Oh, except for I'm recording this in the evening. So tonight I'm taking a look at this sunflower LED light that I got in the last mailbag. It looks just like a UFO or an oddball smoke detector or something like that. But when you plug it in, it does this, which is all fancy and flashy and disco-y enough. However, one thing I did notice when I was doing the mailbag is it's not sound reactive at all. It just does its own thing. It's not remote controllable. It just keeps doing that, which is all well and good, I suppose. But if you have multiples of them deployed in your disco room environment space, they wouldn't be synchronized. They would all just be doing randomly different things, which I don't think makes as good a light show. Anyway, let's bring the lighting back to normal and get inside this thing. Actually, before we get inside it, I want to just point out that the one that I got came with a European plug on it, but the box claims that it works anywhere from 90 to 240 volts, 50 or 60 hertz. So let's just enter do not try this at home territory and see if it will actually run on 120 volts. Yeah, it seems happy to do so. Okay. So that means I should be able to clip that Euro plug off and just put a North American plug on if I intend to repurpose this thing or use it. But for now, let's get back to plan A and take this thing apart. It's got 3 Phillips screws on the back of it and a couple of keyhole slots for hanging it on the wall, which I guess is good. That's intended. That's its intended installation, so why not? I suppose you could also use double-sided tape or something, but I like something that's reversible like that. So with those 3 screws out, it just pulls off. It's got a fancy knot in there for strain relief. And then it's all just on one circuit board. I'm hoping there's no charged capacitors in there. So we have a whole bunch of LEDs around the outside, which makes sense. They look like they're in maybe series parallel groups or something like that. We'll take a look at it in a minute. Anyway, we have a capacitive dropper there. What kind of a capacitor are you? 824J, 400 volts, so what is that? 0.82 microfarads. And then in parallel with that, we have a resistor to bleed that down, which is why I didn't get zorped. That's nice. Bridge rectifier, full bridge rectifier. Interesting. We've got 2 pads for resistors there, and this one's kind of diagonally across them, so I'm going to guess, yeah, that would be series if they were 2 of them, so that's just being one of them. Next to that, 400 volt, 4.7 nanofarad capacitor. So that will be in parallel with all this. So that'll be smoothing order power supply. And then a big chunky series resistor there. And a Zener diode. Okay, another resistor. I may do a schematic of this, I may not. I'm not sure yet. Anyway, another smoothing capacitor there after that Zener power supply, which is presumably knocking us down to whatever voltage this little chip here wants. And of course, this little 8-pin chip here is completely anonymous, because why wouldn't it be? Then from the chip, we go to these 3 resistors. Each one goes to its own pin. That's a series resistor, probably going to the base or gate of these 3 transistors over here, which are 2N5551, which are nothing special. They're just a basic NPN transistor. Okay. And then off of each one of those transistors, we go to these 3 resistors here, which are in series with chunks of these LEDs. And since these LEDs only have 2 pins on them, I'm going to guess that they are RGB color changing LEDs. Although, hang on, I think that guess is wrong, because these are just individual colors, red, green, blue, all the way around. This might be the perfect application for my LED tester here, just to see how these things are wired. I mean, I could trace them out, but could also just do this. So red, green, blue, red. Yeah. So if I go every third one around. Yeah, so okay, I'm lighting up just the red ones. Okay, and I can do the same with the other ones, I suppose, all the way around. So these are just individual single color LEDs, which I guess makes sense now that we know what's going on in here. This is even more basic than I thought, which means this is nothing more than a little 8-pin microcontroller, and it could be replaced fairly easily with any microcontroller, for instance, something that I programmed. I suppose I could also put a Wi-Fi based microcontroller in there and just kind of set it in the middle so I can remote control this thing. Don't really want to do that though. Maybe I will, since this video is super short already. Maybe we'll quickly drop a short schematic, which shouldn't take all that long. Give me a minute, drink them if you got them. Alrighty, that wasn't all that difficult, though. While I was doing that, I took the liberty of replacing the power cord with one that's more regionally appropriate. Anyway, here is my ugly little schematic, and it's pretty much what we expected. So we have the series dropper capacitor with a 470k resistor across it in the neutral, according to the markings on the board. Yeah, it's marked neutral there. Whether it's connected to line or neutral really doesn't matter. Partly because it's a two-prong plug, and partly because this thing is isolated from ground, so it really doesn't matter effectively. Anyway, the live just goes straight to the bridge rectifier. The output from this dropper here goes to this side of the bridge rectifier. This, of course, is a discharge capacitor for that, so that you don't get zorp if you happen to touch it. Coming out of that bridge rectifier, we have the 4.7 microfarad smoothing capacitor. I measured it when it was operating. That's floating at about 50 volts when it's powering the circuit. After that, we have a resistor, which I measured at about 500k, going in series to pin 3 of the microcontroller. Regardless, the negative voltage also goes to pin 8 of the microcontroller and to the emitter of the 3 transistors. I only drew one of them, but the other 2 are coming off pins 5 and 6, and this one is coming off pin 7. We'll get to that in a second. From the positive 50 volts here, we go through a 30k series resistor to the Zener diode, the 5 volt Zener diode, and then onto another smoothing capacitor, and that going into pin 1 to power that. Then down at the transistors, each one has got its own 10k resistor coming off there for base current limiting. As I mentioned, the emitter is going to 0 volts. Out the collector, depending on which LED string, we've got a series resistor, 1k for the reds, 330 each for the greens and blues. Then we have 16 LEDs in series. Yes, I got lazy and only do 3 of them, going back to that positive 50 volts. So there is 50 volts across the LEDs, minus the series resistance drop there. Nothing too surprising. The biggest mystery, of course, is what's inside that chip, and that's just going to be code that is blinking these 3 series strings of LEDs in funky little patterns. So just to prove that it still works after my modification, there we go. And yeah, there's nothing super fancy about it. It looks interesting. Other than that, don't know what more to say about it. I'm not sure. Should I modify this thing, or should I just ignore it? It probably wouldn't be all that hard to modify if I were to add a different microcontroller in there, because that's the only real modification I can see making to it. Anything else? I suppose I could just put couple of 555s in there to blink the LEDs in its own patterns, but I don't think that would be as exciting as it is right now. It might be more predictable. If I had more of these things, I suppose I could link them together somehow. That might be interesting. I don't think it would be worth connecting them to something like DMX controller or something like that. It's not that fancy a thing. I don't think it would benefit from that, but it might be interesting to do some things with. I suppose I could put different shapes of LEDs in there, although that will be a lot of soldering for probably not all that much effort. I don't know. What do you think I should do with this thing? What would you do with this if you had a bunch of them? No, I don't have a bunch of them, and I'm not going to be buying a bunch of them, but I don't know. Anyway, that's all I wanted to really get out of it, is to figure out why it does what it does. So, yeah, thanks for stopping by and indulging in my curiosity. Questions or comments down below. I'll put a link to where I bought this thing if you care, or maybe even a link to the mailbag video where I got it from. I'm not sure. I'll do one of those down below. Anyway, thanks for watching. I'll talk to you later.